Good morning everyone. In today's class we are just going to see about an introduction about EMF. In general, EMF is electromagnetic field. So let us see what is the definition of an EMF, and then we'll just go in detail about electric field intensity and the other types of quantities. So let us see first what is an electromagnetic field. So first, the definition for an electromagnetic field is moving charges. The moving charge will produce a current, and then the current carrying conductor, it produces magnetic field. It produces magnetic field. So the interaction of this electric and magnetic field is called as an EMF. And again repeat, electromagnetic field means it is based upon the charges, that is the moving charge. When the charges moves, it produces a current, and which induces electric field. And then the current carrying conductor, that will produce a magnetic field. So the study of this electric and magnetic together is called as an electromagnetic field. Now we are going to see what all the quantities are there in an electromagnetic field. So which is the basic of EMF, that is the quantities. There are 4 quantities. We are going to see what are the symbol for that and what is the unit of those 4 quantities. So we saw what is the definition of an EMF, which is nothing but the field interaction of electric and magnetic field, E and H. Together, it's a combination as electromagnetic field. Now the first basic quantity is electric field intensity. Electric field intensity. And the symbol for this electric field intensity is E. And the unit for that is volt per meter. The second quantity of an EMF is electric flux density. Electric flux density. And the symbol for this electric flux density is D. And the unit for this is coulomb per meter square. And then the third one, which deals with the magnetic field, so which is magnetic field intensity. Magnetic field intensity. And the symbol for that is H. Unit is ampere per meter. And the last one, magnetic flux density. Magnetic flux density. And the symbol for this is B. Unit for this is Weber per meter square or Tesla. So these are the 4 quantities in EMF, and we have seen the definition of EMF. So EMF is study of interaction of electric and magnetic field, and we have seen what are the 4 quantities of an EMF along with its unit. Now we are going to see in detail what is electric field intensity and how do we arrive this electric field intensity. In general, a field is a place where the force is experienced. Field means what? It's a place where the force is experienced. So let us see what is electric field, and then we'll find out the formula for that. So electric field is the force per unit charge. Electric field can be calculated by the force per unit charge. As we all know, we can calculate the force between any 2 charges. Okay, a force between any 2 charges. Let us consider the first charge, let it be Q1, second charge, let it be Q2, separated by a distance D. So the force between these 2 charges, that's what we are going to find out now. For that only, we are going to apply Coulomb's law. So electrical field can be calculated by F by Q, which is force per unit charge. And force, to find out the force, we have to use Coulomb's law, where Coulomb's law states that the force between the 2 point charges is directly proportional to the product of 2 charges, that is Q1 into Q2, and inversely proportional to the square of the distance between them. So we can write this as F equal to Q1 Q2 by 4 pi epsilon D squared. So this is the force formula. Then as I said, electrical field is what? A moving charge will produce a current, and this charge in EMF, it can take in any of the forms. It can be a point form, it can be in the form of line, it can be in the form of surface, and it can be in the form of volume. So this charge can be in any of these forms: point form, line, surface and volume. If it is a point form, the formula for Q is just a representation as a point charge, let it be Q. If it is in the line form, let us assume a line integral where the charges are placed. So for that, we have to consider a density which is called as line charge density, and the symbol for that is rho L. Unit for that is coulomb per meter. So this charge density, rho L, so Q can be written in terms of rho L into dl. It's a line charge density. I said the charge can exist in any of these forms. If it is a point form, we can just write it as Q. If it is a line form, then we have to analyze in terms of its density, which is given by Q equal to rho L into dl. And if it is in the surface, and then the unit for that is rho S, coulomb per meter square. So the charge can be given in terms of surface integral, which is rho S into ds. And finally, the volume, where the charge density here can be rho V. So charge formula is volume integral rho V into dV. So we saw how to find out the electric field intensity. Electric field intensity, it is force per unit charge. F can be calculated by using Coulomb's law, and charge can exist in any of these forms.